Types of machine learning problems and the workflow. So here, let's talk about the main types of machine learning models. And the first main type is the supervised machine learning. And supervised machine learning learns to predict a target or outcome value from labeled data. And within supervised learning, there are two subtypes. One is the classification. So that's when the outcome variables are discrete or categorical. So things like nominal categories, like is this an apple, is this an orange? But also um, uh, ordinal categories, like is this um, good, semi-good, not so good, neutral, and so on. And then regression, which is when outcome variables are continuous, like decimal points. So things like temperature or the cost of something. Now, when we're talking about integer, so values, so things that are integers, so like count data, it may go either way depending. We need specific models to determine which one's the best for depending on the context. So let's talk a little bit about supervised learning. So supervised learning, here's an example, and the example we're going to be working with. It's suppose you have a bunch of fruits, and you want to determine, you want to be able to predict if the fruit, what kind of fruit it is, based on certain features of the object. So this is not a human, we're working with computers, so each object has certain features like size, color, shape, and so on, weight, dimensions, and then they have an actual name like apple or lemon or orange. So the idea is that we'll have this training data, and the training data is going to have all kinds of information about the fruit, and then we will have also a target or outcome label that we want to train on and then be able to predict. So this is the label data, meaning that we have the sample with the characteristics and then also the actual label. And then we'll feed that into a function, and the function essentially has an X input, and the X is a multi-dimensional array, means it's all kinds of columns and features, not just one value, but multiple instances and multiple features. And then we'll predict and be able to predict the target value. So the classifier is this function that is built from the training data. And then once we build the classifier and the classifier is built, we may get a new object. We can see here in the image that this is an orange, but the computer doesn't know. And the new object just has all kinds of information, like, you know, this is the color, and this is the size, and this is the shape. And then the function itself will, based on the training data, the function will put out a label. And this label may be orange if it predicts it correctly, or if not, it would predict apple or something like that. So that's the main idea of supervised learning. So where does the labeled data come from? Well, it comes from a hidden human being inside of a box. No, I'm kind of kidding. So that's a joke in reference to the Mechanical Turk, which was this chess playing machine that was developed by Turkish individual, where he would go around showing kings how a machine could play chess. I think is the 1700s now, or maybe even early 1800s. But the thing is, it wasn't really a machine. There was actually a person inside the box playing the chess. And funny thing is that, of course, now we can make machines that can play chess. But that's the reference to a Mechanical Turk. Now there's an Amazon Mechanical Turk, so Amazon the company. And this program of Amazon is actually a platform where people can get paid to do tasks like Well, labeling data, labeling all kinds of data. So we will provide a data set to people, and they may be Americans, they may be in other countries, in developing countries where the currency exchange is much lower, so they can get paid much lower compared to the dollar. And then we'll give them all this data set, and then they just mark, oh yeah, this is like this is like that, and so on. So a lot of work actually does come from Mechanical Turk or applications like that, but essentially we need humans to actually label the data. And there are two ways that we can get labeled data. So one is from explicit coding by humans. Humans go and either enter the data in the data set, or at least we can have maybe some existing processes, some that is semi-automated, but a person goes and then validates, yes, this here is a tiger, and these are the actual speed, and this is the weight. This is another tiger. This is a dog, and we examined. And then this other object, this other instance is a tiger, and these are the speed, and these are the weight, and this is the name, and so on. So the label data needs to at least have some strong validation from humans to make sure that we are using good data that we can build reliable models from. Also, we can have data that is kind of from an implicit coding of actions that are not related to the labeling itself. So for example, when you, let's say you're searching for a flight on one of these flight websites, Google Flights or any other flight website, well, every time you search for a flight, you're doing some kind of actions, right? So let's say you want to go from Detroit to New York. And then let's say that you go from Detroit to New York, and then you click on the first item, the best, and you click here. So your click here is a kind of action that can be recorded. And this action would be something like, we can put it in a database, and that is the person searched, from to, and the person searched from Detroit to New York, and then did they click on the first suggestion for departing flights? Yes, they did. They did click. Or another person goes and searches for the same flight, because a lot of people are traveling from Detroit to New York, and then did they click on that first suggestion? No, they didn't. And so on. So we can kind of have a coding and develop a database from this, but they are kind of an implicit coding of unrelated actions. And then the other major type of machine learning model is the unsupervised learning. So this is where we find patterns in unlabeled data. And this may be finding groups of similar characteristics, or finding instances that are very unusual to the data. So let's talk about a bit how this works. So for example, let's take a look here on the first one, on the clustering approach. So that's finding clusters of similar users. So perhaps you run a website and you want to know what kind of users are on your website, and you plot a graph of the number of pages that people access along with the time on the site. So for example, there may be some users, for example, this one here, there's one person, so each dot here is a person. They access very few pages, but they spend some kind of medium time on the site. Now there's some people that access a lot of pages, but they actually only spend few times. So I see this person here, let's say it's Joan. Joan accessed like 30 or 40 pages, but she only spent like 10 minutes. Okay, and actually there's a lot of people like Joan. And then there's people that spend a lot of time on the site and access a lot of pages. So what an unsupervised algorithm can do is find these sort of natural or observable groups or clusters in the data by itself, based on its own calculations, which can get pretty complex. But the idea is that the algorithm can find these clusters. So here we may have something like careful researchers. There's a group of low page access but a lot of time on site. There are quick browsers, low time on site, but lots of page access. And there's power users that have both lots of power, lots of page access, and lots of time on site. So that's clustering. Another unsupervised kind of algorithm is outlier detection. So, for example, maybe you run some server, you have some sensitive information, and you notice that people usually, let's say this is time of day, this is like 12 p.m. and this is 12 a.m. and this is 12 a.m., 12 p.m., like this is 8 a.m. I'm not sure, something like that. So you notice that people usually access your server. They access X amount of servers, or this X amount of servers here at these specific times, kind of like in the evening and then maybe in the morning. Now, maybe you start noticing that some people are accessing the sites at a very awkward time, and they're accessing many different sites, many different servers. Okay, so you can notice that these accesses, activity, are very different than the other ones. So we may call them kind of like outlier or abnormal behavior. So we can use algorithms that can identify these abnormal behaviors. It may even look a little bit like clustering when we graph things. You can see groups. There's one big group here, and there's a separate group here, and there's a separate group here, and then also there's two groups here, one on top and one on the bottom. So it's slightly different though, but they do have some similar characteristics. And that's a little bit about unsupervised learning. And here an image of a basic machine learning workflow. And actually, I'm going to pause here. I'm going to come back to here because there's some other things about this that we need to discuss.